Okay, so this one is, so for the third question, also to draw the Lewis structure for XeCl4, show all lone pairs and identify the geometry. What are the approximate bond angles, and is it polar or non-polar? So, so for xenon, that's a noble gas, so we've got 8 valence, and then in chlorine, we have 7, and there's 4 of them, so that's 28. So in total, we have 36 valence. So each of the chlorine atoms will have 7. And xenon typically has 8. We obviously want to be able to bond to 4. And then that's 5, 6, 7, 8. We know xenon can become hypervalent, so I'm just going to add in the lone pairs kind of around it like that. And so obviously we can't really count xenon octet for xenon because this is an expanded octet. And so then there's our bonds. If we count everything up, there's 8, 16, 24, 32, plus 4 is 36. Okay. If we draw the molecular structure, it would look something like this, where the lone pairs I have going above and below xenon. And I'm using wedges and dashes to indicate a bond coming out of the page and into the page. And so this is a square planar molecule. So in Vesper theory, this would be either B2, AX4, or maybe A2, depending on what you want to call the lone pairs. And so this is a square planar molecule. So that's our geometry. Each of these bond angles in here would be 90 degrees, as it's 360 around the circle. So our bond angles are 90 degrees, and then this is a symmetric molecule, and that means it's non-polar, right? So each of the bond dipoles between chlorine and xenon will perfectly cancel, leaving you with a zero dipole. So non-polar, so the dipole is 0. I believe that's all the questions that are in there. Showing all lone pairs, identify the geometry, what are the approximate bond angles? Yep, okay. So just checking to the solution here. So we get a square planar with bond angles of 90 degrees. Perfectly symmetric, so all the dipoles cancel, giving us a 0 dipole. So that looks good.